Welcome back to our series of HRMAn tutorial videos. With this video we'll show you how you can use an additional workflow created by us to create your own learning dataset for the machine learning algorithms that HRMAn uses to classify objects it has identified in your images. So for instance, it is used in the infection analysis to classify vacuoles based on how many pathogens they contain. First thing you gotta do is to image some samples on your microscope and try to aim to get as many pathogens as possible, because the bigger your data set is from which HRMAn can learn how to classify objects correctly, the better your classification and the better your results will be. So I only have a couple of images here with maybe 100 vacuoles, but this is just for the purpose of this tutorial. If I was to create a dataset with which I want to work in future, I would aim for several thousands of these vacuoles. So here I've got my images. It's just 3 different fields from 2 wells. I imaged them in 3 colors. The only thing I am interested now in is on how to segment intracellular vacuoles properly and then classify them. So for this purpose you can use the following workflow, which is called create learning datasets. You have to do the same thing as always. You first need to tell the program where to find your images. So I'm just gonna navigate to the directory here with the TIFF images, choose, click apply, and also click OK, and then you can execute this node by clicking on the little play sign in the menu bar, and then the program will know where to find your images. So let's first check on how our images look like. So we can execute this little node up here. It's an image viewer. Then again, the program will ask you what you did to be able to classify the data correctly. So here I imaged with 3 different colors. I stained for the nuclei, I stained the cells, and I had GFP expressing toxoplasma. So it's 3 channels. Then the program wants to know what you can see in which channel. So I know that in channel 1 it will be able to see the nuclei. In channel 2 it will be able to see the pathogen, so I'm going to put a 2. And in channel 3 it can see the cells, so I'm going to put a 3. And then the program's going to double check with you again. So I told him, okay, in channel 1 you'll see nuclei, in channel 2 you'll see the pathogens, in channel 3 you'll see cells, and that is correct. So I'm going to put a 1 here and click OK. Then it also wants to know the magnification you used. This is important so that the segmentation works properly. In this case I imaged with a 40x magnification. And the pathogen I used is toxoplasma. What we're planning to do is that we're going to expand this context box. For instance, add another option here, which would be unknown, that you could choose, and then this would just segment your pathogens, and you could then create datasets for literally any other pathogen that you can think of and that you want to work with. But in this case I infected with toxoplasma, so I'm going to tell the pipeline to analyze for Toxoplasma, because this will set all the filters accordingly. It asks me that I want to create a learning dataset for Toxoplasma. The magnification is 40, and that is correct again. So now the program is actually going to start working. What you can see in the console, and what you can also see here, so these little traffic lights turned yellow and this traffic light turned green, which means the execution of the node is completed. So by right-clicking on it again and navigating to View Image Viewer, we're now able to see our images. So here in channel 1 we got the nuclei, channel 2 you had Toxoplasma, and in channel 3 we have the cells. And if we just look at the images again, here on the right hand side you can set the zoom. I usually set it to 50 because then you can see the entire image. So these are the nuclei. Not very beautiful, but we're able to see them. This is the Toxoplasma, so you can see some of them actually started replicating here already. For instance, here we would have 2 vacuoles with 4 pathogens each. Here we would have vacuoles with 2, and then we have lots of vacuoles that only contain 1 parasite. And then the last image here is the cells. If you then further want to check how HRMAn is segmenting your images, so we're going to first let him segment the nuclei, execute this node again, and navigate to Image Viewer. And what you'll see, this is what you recorded, and then if we set the zoom to the same, this is what the segmentation comes up with. So you see it did a fairly decent job here. For instance, here the nuclei that are on top and that touch the border of the image, they are excluded because we were not able to capture the entire object. And then we can do the same thing for the pathogen labels. It's going to take a short while, but then it's done. Again, here these are our pathogens that we imaged, and if we then look at the segmentation and set this to the same zoom, you can see that it did a pretty good job here segmenting all of the vacuoles. You can see here the 4 individual ones are segmented individually. Here the 2 big vacuoles that almost touch each other were still segmented as individual objects. And that's basically it. What you can do, you could also check your cell labels. I'm not going to do that now for the purpose of time, but we can execute these 2 nodes, and these are the important ones in this workflow, because the CSV writer node will actually write the CSV file to your hard disk, and it's going to contain all of the attributes you'll need for the machine learning algorithms to be able to classify your objects. And it's also going to contain an empty column where you will have to type in how many parasites per vacuole you see. And the way you do this is that you work with this node, the image viewer. Because if we now open this and look at our images, so you'll see that the workflow has cropped out the individual objects from your image. So I'm just going to click on the image to open the image viewer. Make this window a bit smaller so you can see, if we zoom in, that this is 1 parasite. Then this, if we move down with these arrows, this would be 1 again. Here we would have 4. This would be 1, this would be 1, and so on and so forth. Now we can open this CSV writer node and check where it has saved the data. So this is this file here, and you can see the table contains some information on the individual vacuoles. So you'll have the number of pixels, which is basically the area it is covering, circularity, perimeter, convexity, extent, diameter, minimum fluorescence, maximum fluorescence, mean fluorescence, geometric mean fluorescence, and total fluorescence. And additionally, you'll also get the vacuole name. So the way these things are named is that this is the field name. So the field we imaged in our first couple of images was in well B2 and field 37, and then this would be the first vacuole, this would be the second, this would be the fifth, sixth, eighth, ninth, and so on. The reason why these numbers are not continuous is that for probably vacuole 3 and 4 were just some artifacts that were filtered out and do not actually represent toxoplasma, but it was still picked up by the pipeline before the filtering. So what you have to do now, and that is a bit of the painful part, is that you'll have to fill in this table. The way I usually do this, I mean, you only have to do this once, but it's still quite a lot to do, is that I just open these two windows next to each other, so side by side on your screen. And what you'll see is you'll have the vacuole name here. You can also see the vacuole name here, and you can see your image here, and then you just have to fill in the table. So the first vacuole contains 1 parasite. Then we move on. Sorry for that. The second contains 1, the third contains 4, the fourth contains 1, so we can type in 1, 4, 1. Then it's 1 again, 1, 1, 1, 2, probably. Based on how they look like. So we got 1 here, and then there would be another 1 below in this orientation, and so on. And that is how you can create your learning data set. The only thing you need to do in the end is to delete this column. This is quite important because otherwise the HRMAn workflow will get confused. So I'm just going to delete this column and save this file, and then you have created your own learning data set, which the machine learning algorithm will use to classify unknown objects. And just to give you an example, so when I'm running HRMAn on my computer, so this is my learning data set for Toxoplasma infection, and you can see I not only have 200, but I have something like, if we move down, yeah, something like 35,000 vacuoles annotated, and this usually results in really, really good classifications. Thank you for watching, and I hope that you'll be able to use this little tutorial for your work to create your own machine learning datasets for your pathogen of choice. And again, if you have any questions, comments, or feedback, feel free to contact us through our homepage, HRMAn.org. Thanks for watching.